Uh, Good morning, friends. Today we'll see the following problems regarding the topic relations. So, first question is to determine whether each of the following relations are reflexive, symmetric, and transitive. So, the relation is given in the set A, which is 1, 2, 3 till 14, defined by the relation x comma y, which is given by 3x minus y equal to 0. First, let's see what are the ordered pair which belongs to this relation. So let's check, say x is equal to 1, y will be equal to 3 times x, which is equal to 3. 3x, that is 3 times 1, 3 into 1 minus y, that is 3, is equal to 0. Therefore, first order pair is 1, 3. If I take x is equal to 2, y will be 3 times 2, that is 6. So this also satisfies the relation because 3 2s are 6, 6 minus 6 is 0. And when x is equal to 3, y is equal to 3 3s are 9. So this also satisfies because 3 3s are 9 minus 9 equal to 0. X is equal to 4, then y will be equal to 3 times 4, that is 12. 3 into 4 minus 12, that is equal to 0. Yes, this also holds good. When I take x is equal to 5, 3 times 5 will be 15. But this does not belong in set A, so I cannot take this. So our ordered pair which belongs to the relation is 2, 6, 3, 9, and 4, 12. So we'll now have to check whether it satisfies the following property. First, let's take reflexive property. Reflexive property is one which is given by a number related to itself, that is a is related to a, then only you say that is reflexive. Suppose if I say 1 comma 1, then it is reflexive because 1 is related to itself. But in the following example, none of the element is related to itself. Therefore I say the given relation R is not reflexive. We'll next move on to symmetric. What does this mean? Symmetric is, if I take any element which belongs to the relation a1 comma a2, this implies if a2 comma a1, if this is also in the relation, then you say that is symmetric. Suppose if I take, for example, 1 comma 3 which belongs to R, then 3 comma 1, if this also belongs to R, then only it is symmetric. But 3 comma 1 does not belong to this relation. Because 3 times, if 3x is 3, y will not be equal to will not be equal to 1 according to the given relation, and it does not hold good for the condition. Therefore the given relation R is not symmetric. Next we'll check out for the third property, that is transitive. So this is like this: when a1 and a2 belongs to a relation and a2 a3 belongs to the relation, then this implies a1 comma a3 also belongs to the relation. So we'll take an example. Say 1 comma 3 belongs to the relation, yes, and 3 comma 9 belongs to the relation. Then this implies 1 comma 9 should belong to relation, given relation. But 1 comma 9 is not in the given relation. Hence this 1 comma 9 does not belong to relation. Therefore I can say R, the given relation R is not transitive. Hence the given relation is neither reflexive nor symmetric nor transitive. I hope you are clear. Next we'll move on to the next question. In this case, R is defined in the set from 1, 2, 3, 4, 5, 6, which is given under the condition a comma b, where b is equal to a plus 1. So we'll first write R is equal to the following ordered pairs which comes under this condition. That means if I say, if I take A, B should be A plus 1. That means B should be 2. Second, if I take A as 2, then B should be A plus 1, that is 3. If it is 3, then 4 will be B. A is 4, 5 will be B. If A is 5, B will be equal to 6. We can only write till so much. It satisfies the given condition and belongs to set A. Now let's check for one by one of the given property. Reflexive. As you can see, the ordered pairs, none of the numbers is related to itself. So I can say the given relation R is not reflexive, because you cannot find any of the ordered pair as 1, 1, 2, 2 or 3, 3. Then we'll move on to the second one, that is symmetric. In order to be symmetric, a relation should be like this. If 1, 2 belongs to R, then 2, 1 should also belong to R. Just check. If I take A as 2, B should be equal to what? A plus 1. That means it should be 2 plus 1, which is equal to 3. But in this case, B is equal to 1. So that does not belong to the relation. This does not belong to the relation. Hence, the given relation R is not symmetric. Next, we'll check out the third one, that is transitive. So in this case, if I say, for example, if I take 1, 2, which belongs to R, and 2, 3, which also belongs to R, then 1, 3 should belong to R. Just check whether 1, 3 belongs to R. No. So this does not belong to R. Therefore, I can say R is not transitive. So the given relation is neither reflexive nor symmetric nor transitive. Next we'll see an example, that is relation in set A, where when A is 1 to 6 and R is given by the relation Y is divisible by X. So we'll check out for one by one property. Reflexive. Reflexive means what? Any number related to itself. So if I say 1, 1, 1 is divisible by 1 because Y by X, 1 by 1. Yes. If I take 2, 2, 2 is divisible by 2. Therefore, I can say R is reflexive. Correct? That means any number is divisible by itself. Any number is divisible by itself. Next we'll check for the next property, that is symmetric. In this case, if I take 1, 2, that means 2 is divisible by 1. Yes, true, it belongs to the relation. Then this implies that 2, 1 also belongs to the relation. That means 1 by 2 should be divisible. That 1 by 2 is not divisible, which therefore it does not belong to the relation. Therefore, R is not symmetric. If I take third one, that is transitive. If I take any example, say x, y, which belongs to R, that means y is divisible by x, and y, z belongs to R, that means z is divisible by y. Then what it implies, x, z also belongs to R. That means z is divisible by x. Let's check whether it holds good. Suppose if I take 1, 2, which belongs to R. Why? Because 2 by 1 is divisible. And 2, 4, here also 4 by 2 is divisible. Then 1, 4 should be divisible. So in this case z by x. So 4 by 1 is 4. So that is also divisible. Therefore R is transitive. So the given relation is reflexive and transitive, but not symmetric. I hope you have understood. Next, we'll move on to the question, that is, let L be set of all lines in xy plane and R be the relation in L defined as R given in such that L1, L2 which is parallel to each other. L1 is parallel to each other. So you need to show what? You need to show R is equivalence property, equivalence relation. That means equivalence means it should be reflexive. Equivalence means it should be reflexive, symmetric, transitive. All three are holds good. Then you say that given relation is reflexive. Now, and also they are told to find the set of all lines which is related to the line that is given by the equation y is equal to 2x plus 4. So first we'll check out for reflexive property. If I take any line L1, any line is parallel to itself. So I can say L1 is parallel to itself. So I can say the given relation R is reflexive. You can take any line L2, L3, L3. It will be parallel to itself. If I take symmetric, we'll see whether it holds good. If I take L1 and L2, two lines, I say that L1 is L1 is parallel to L2. Then this also implies that L2 is also parallel to L1. Then if I change the order, if I say L1, put L2 first and L1 next, this will be parallel. So symmetric, that means R, the given relation R is symmetric. Because all these two belongs to R. That means L1, L2 also belongs to R and L2, L1 also belongs to the relation R. Next we'll check out for the third property, that is transitive. Suppose if I take an example of three lines, that is if I say L1 and L2 parallel to each other, which belongs to the relation. Then I take again set of two lines, say L2 and L3 also parallel to each other. So in this case L1 is parallel to L2, in this case L2 is parallel to L3. Therefore I can say L3 is also parallel, L1 is also parallel to L3. That means if I take any three set of lines, then L1 and L2, these two lines are parallel, and if I take another line, L3. So if I say L1 is parallel to L2 and L2 is parallel to L3, therefore L1, line L1 and L3 are also parallel, which is belonging to the relation. So therefore I can say R is equal. R is equivalence because it holds good all the three relation, that is reflexive, transitive and symmetric, everything holds good. So R is reflexive. Now let's check for the next thing. You need to, they have told to find the set of lines which is related to the line, that is y is equal to mx plus c. So how to do that? So let's take, for example, let me clear this. Say, for example, if I take an equation y is equal to x plus 4, if two lines are said to be parallel, then m, that is the slope, should be equal. So slope will be equal to 2. Then only any two lines will be parallel. So the one which is changing will be the constant, that is c. So I can say all lines, set of all lines which is related to the line will be y is equal to 2x plus c, where c should belong to the relation. So this is the set of all line which will satisfy the given condition of parallelism. I hope you are clear.